All right, hello everyone. It's been a while. Haven't done one of these for quite some time, so it's good to be back. Hopefully everybody's doing really well, whether it's a morning for you like it is here in sunny Ballarat in Australia, or if you're having a good evening. I hope everybody's having a good weekend. So yeah, like I said, haven't done one of these for a while. A couple of little technical gremlins, as is probably traditional, particularly given I haven't done one of these for a little while. But I think we're all sorted now. Hopefully everyone can hear me okay. I'm trying to keep up with chat at the same time, so let me know if you can't hear me or if things aren't working particularly well, and I'll try and address those. But okay, what are we going to talk about today? I'm going to talk about 3 new pieces of hardware for Speeduino. These have been in the works for a little while now. One of these is going to be something that's already been released and is out there available today. One of them is going to be something that's about to be available. And the third one is something that's fairly close but not quite here yet. So I won't be too far away. The first of which I'm going to talk about is the one that's already been released. And by the way, if you do have any questions, I will try to keep up with chat as much as I can. I can't promise. I'm following chat along with my phone because my second monitor is not working at the moment, which is a little bit frustrating. Thanks, Windows. But we'll do the best we can. So the first piece of hardware that I wanted to run across today is one that's already been released, which is the new version of the through-hole V0.4 board. I'll do a quick run through of the circuits of this one, and I'll do a quick demo of just what it looks like. So bear with me a second. Let me just pop it over here. Okay, let's see if the tech gods work here. Try that one. All right, so apologies because it is a little bit dim, particularly because it's a black board, which doesn't help. But this is something many of you will have seen before, and it's the new through-hole V0.4.3D board. Look, it's not perhaps the most exciting thing in the world. Let me see if I can get a little bit more light on that one. Try that. But it has a couple of really nice new features and things that I wanted to just call out because it's a big step up from the through-hole board that we've had in the past. Most of you will have seen that we've had for a long time a surface mount V0.4.4 board, which has sort of been probably the one that we've been aiming for most DIY and do-it-yourself type crowd, and it works absolutely really well. It's become a nice mature design. Weaver from WM-Tronics and myself have been working on that one for a little while now. Huge effort and a big credit to Weaver on that one because he's done an amazing job on the work he's done for it. And it's come a really long way since it was first developed. However, what's always been one disconnect, I guess, is that it's been quite a long way ahead of what the through-hole boards have been. And whilst it's not the same demand, there has certainly been a group of people for whom the through-hole boards have always been very important, and something that they've always wanted to do themselves. And I completely understand that. That's totally fine. So what I've tried to do with this new board is bring its feature level up to the same as what we get on the surface mount one. Now that's a pretty big challenge because purely from a physical point of view, your through-hole parts are much larger than your surface mount equivalents, and it can be much more difficult to lay things out on a board that is physically exactly the same size. Couple that with the fact that in the surface mount world you have a much greater selection of driver ICs and things that you can use, and you can have very small little dual MOSFETs that will work in a surface mount world that you can't even hope to get an equivalent of in the through-hole world. So it's been a bit of a challenge. I'm pretty happy with how this has turned out. It's a really fantastic little board. Its circuits are much more up to date than the previous version that we had. And I just wanted to give a really quick run through of what's on this particular board. So if I flip back to the schematic for a minute. Okay, so I'll just do a really quick run through of what's on this, and you can see why it's been such a challenge to get it to where it is today. So much like the V0.4, we've got 4 channels of fuel and ignition outputs. No real changes here to what we saw in the previous version. The only major difference though, and this is in the board layout itself. Let me bring that up. Okay, the major difference here, this is the board layout for anyone wondering, is that all the injector MOSFETs here now are designed to lay flat. And believe it or not, there's a very good reason for why that's the case, and I'll get to that in a minute. But previously, these MOSFETs were designed to be vertical, and that was fine, always worked without a problem. But having them lie down like this has a couple of benefits. One, it reduces vibration because that they can actually be attached via the hole in the tab on them to the board itself. And they also reduce the height of the board, and I'll get to why that's important in a minute. It's the same also for the voltage regulator on this, is also lying down and now heat sinked through the board as well. So previously that had no heatsink other than the tab itself. You could attach it to the case, and that did work fine. These are linear regulators, they get warm, but it was never too much of a problem here. But this one will now lie down and solder to the pad on the board itself for some heat sinking there. The power circuit itself has been significantly updated and is now a much more modern version of what we had on the previous version. It's not dramatically different in the sense that it's going to work differently, but it has much more available components. It has a little bit more protection built in. And it's changed out a few things, like going from the varistor back to a TVS diode and things like that, which should just be a little bit more robust. The biggest changes really have come about in the output stages, where previously the earlier through-hole board left a lot of these circuits out, and they were up to the user to add them on in the proto area if they were needed. This was something that came about in the very early days of Speeduino, and I'm talking 5-6 years ago at least, and just sort of never really got updated. It was the same board that had been carried through. The through-hole one hadn't had major redesign for a long time, so it kind of just got carried through. And whilst it was good and it was flexible for people, it wasn't what most people were after. Most people were after a set of circuits that were there, ready to go, and that they could use out of the box. And that was certainly what the surface mount boards had, and that this one was lacking. These have all been added now. So you've got all of your drivers and things on board now for your fuel pump, your tacho, your fan, boost control if you want it. There's 2 spare high current or middle current outputs. There's an idle driver. All of those things are now on board. It was a challenge to get all these things fitting. Pardon me. But there's a combination of fairly common ICs that I've used, or fairly easy to get ICs, which is pretty important at the moment, that we're using for these. So the first of these is the good old ULN 2003. Now this was the recommended chip that we use on the board previously, and I've now just simply wired it in permanently. It uses the same pin out as what you would see, or what you would use on the surface mount board, so it's fully compatible with that. This is a great IC. It really is. It's been around forever. It's not a MOSFET. It's a Darlington pair, but it works pretty well for what we're looking at, which is mostly relay driving, but also things like the boost controller. You can do some really good things with it, like pair the outputs. So it's got 7 outputs straight away. You can pair them together to double the current, or nearly double the current on these. It has things like series resistors and pull down resistors already built in, so it makes for a nice compact package on the board. It is still a big chip physically, from an IC sense. Now, this is a really crowded board, and it can be somewhat hard to tell what's actually going on here, but this is the IC that we're talking about here. So it is moderately large. It's got, what are we? We're a 16-dip package here. So still fairly large, but it gives us an awful lot of outputs to work with. So it's a handy one to have included. Just to confirm, David, this is not the 0.4.3C. It's the D version, which is the brand new one that's just come out. The other drivers that we've got on here that maybe require a little bit more capacity. I didn't originally, when I worked on this design, I put 2 of these ULN2003s. Unfortunately, I just couldn't make them fit. They simply did not have the room on the board to include a second one of those. So what I've done is added these single channel MOSFETs, one for a spare high current output and one for the idle output. They are where are we? That one, IRLD 024. That's right. So a single channel MOSFET, quite a nice little MOSFET and easily available. It doesn't have things like the series resistor and pull down built in, but we can add them on. What is nice about them is that you see there are these ones here, one there, one there, and one down here. They can carry quite a lot of current. I think the version I'm using is a 2 amp output one, which is about as good as you can get in the through-hole MOSFET world for something like this without going to a big TO type package. So these are nice and compact and do what they do really well. They have a nice tab on them which provides some cooling capacity. And yeah, in my testing they've worked really nicely. Okay, the other major change, there's been some added changes with some fuses and things that have been added, some poly fuses. All of those outputs, by the way, if you want full compatibility to the older through-hole board, do have jumpers on them that can be severed, solder jumpers here that come pre-closed, and they can be cut through if need be, if you don't want any of those outputs working in their default form. So that's the new through-hole board. It's available at the moment, has been available for a little while now. Seems to be working really well. I've had some great feedback on it from people, and everybody seems to be pretty happy with that. If you have a look at the board itself, if that's going to work, there we go. You can see around here you've got the areas where the MOSFETs will sit, which again takes up a lot of real estate, but is worth it. And the other big change here, and I should have got one of the older boards to compare here. Hold on, let me just grab one. Okay, so that's the old board and the new board beside each other. The other big change that you'll see, or 2 big changes actually, we've unfortunately had to lose the proto area. It simply does not fit with all these new circuits built in. I think it's a reasonable exchange of capabilities there, because most of the things that people were using the proto area for are now built onto the board anyway. So, hopefully I think that's a good trade-off and not something that people will find too disappointing. Just looking at chat here, could vertical free resistors free up some space? They could. I'm not a big fan of vertical resistors. Whenever I've used them in automotive work before, unless you pot them, they have a lot of vibration issues, I found. It depends on the resistor and how thick the wire is, how thick its lead is, and those sorts of things. But something I'd prefer to avoid if I can. They work fine if you pot them, but it's similar challenges to what you get with some big torque capacitors and things. The other thing that you might notice if you've got very sharp eyes is the movement slightly of the map sensor location. So it's moved from being down here slightly to just being pushed up a little bit. And there is a very important reason for that. And the reason for that is the next thing that I'm going to show, which also leads into the reason why I've gone for the flat-mounted MOSFETs. And it is this. Hopefully you can see that. So it's a little bit dark, isn't it? Black on black never quite helps very well. But this is a board with a 39-pin locking connector attached to it. And it is, if we look inside, nothing more than a shield on top of a V0.4 board. It doesn't want to open for me. That's okay. I might just show you a picture of it instead. But the idea is that this is a shield board that plugs in on top of the V0.4 and gives you a nice proper automotive connector on it. So let me switch back to this. Okay, if this is going to work for me. No, don't want that. I want this one. Okay. All right, so this is the board itself. I'm not sure why that case is not opening. But in essence, we've got a board that sits over the top of a V0.4, and this is the reason why the height was critical and why I wanted to flatten those MOSFETs out. Having them sit up tall means you can't easily get another board over the top of them without having some big cutouts and things for them. I do have a cutout up in the corner for the screw connector, which remains in place. But otherwise, this simply plugs in on top of the V0.4 boards, either the new surface mount board or this new through-hole board, either work, and provides you a nice locking connector that is a big step up from just trying to use the IDC connector itself. Now, originally when I designed these first V0.4 boards, this was always the intent. It was never to necessarily use that IDC 40 interface directly. It was to have other boards that plug in over the top, be they application specific, so you can stick your own car's connector on there, or have something generic like this. The idea was always to have another board that plugged in on top that you could swap in, swap out, do whatever you needed with it, and it would make life really simple for you. And be as compatible with different systems as possible. It never really happened. Other things sort of got in the way, and I never really got around to designing any of these boards. I did one for the early MX5 Miatas NA6s, but then they morphed into their own plug and play unit, which was a much better solution than this was. But this was always the intent and what these boards were meant to be. So I'm going to... This one's not quite available yet. It will be shortly. I'll have these in production fairly soon because the current revision of these does seem to work quite well. But the hope is that when I release the rough layout here, people will be able to take it and modify it and create their own custom boards that work with their car's pinout without too much difficulty. All you'll need to do is remove this 39 pin connector that I've got here and add your own and wire in the traces. Everything else here will remain the same. So the IDC connector and the VR spot here and the stepper motor driver here will all be correctly positioned. They slot straight in over the top. And it makes it really easy to create these kinds of adapters. So this connector itself, if I jump back here, is very much in the same family as the locking connectors that I use on the drop bear boards. I swing around here. If I can get this right the first time. No, that way. It just locks on in place. Very, very simple and easy to use. They're very, very simple to crimp and connect, and they seem to work really well. And they're very readily available and quite cheaply available. So a nice little addition to the V0.4 family. I should have mentioned the reason why the map sensor movement was critical here is because of the physical layout of this connector. Unfortunately, with the original map sensor placement, and I'm not sure how well you're going to be able to see it here, but with that placement, it just gets a little bit too close to the connector here. And whilst it does work, it was really too tight, and I couldn't move the connector over to the side any more than I have. And I just couldn't make it work in a way that I was really happy with. So this compromise moves the map sensor slightly, and so we get plenty of clearance. It will work with the older boards, but you need to be aware that you'll have to use quite thin hose to connect the hose on. It all lines up and it looks like it should work until you go to put both the connector itself on, which you can see has a moderately large housing, and then you try to get a hose on top of the map port, and you find that you're just running out of space. Whereas this way is well, there's enough clearance, if not plenty of clearance. There's enough, so that works reasonably well. And hence the unfortunate need to move the map sensor locations a little bit. So that's fully compatible then with the any of the V0.4 line that end with D, and will work okay-ish for the earlier boards. These ones I'm hoping to have out and available maybe in 2 months' time. The other thing I should mention, by the way, is that it includes the VR sensor circuit, VR conditioner circuit built onto these. So if I flip back here, we've got the Max 9926 VR conditioner built on to this. So much like the more generic boards and those sorts of things, you can just flick between VR and Hall, and you've got everything built in. Okay, let me just check chat and make sure this works fine. This all, by the way, just slots straight into the standard Hammond case, which is what I've got it in here. The faceplate that's on there at the moment is just a 3D printed one, but much like the MX5 Miata plug and play units, I'll be getting those laser cut and powder coated versions of those. Okay. Will the connector board come with male and female? Yes, it definitely will. I don't have plans yet to do a flying lead for them, but that may appear down the track. But yes, it will absolutely come with both sides of the connector and all the pins that you need. Is it in GitHub? Not yet, but I will have it out there fairly soon on GitHub. Okay, yeah, a couple of questions about Speeduino. I knew they'd be coming. I'll talk about that a little bit at the end. But okay, moving onwards and upwards. Let us move to what probably a whole heap of you are here to see, and that is drop bear boards, or drop bear units, I should say, because these are more than just a board. Okay, let's get this in the right spot. Now, apologies, my camera is not the greatest over there, so it is a little bit dark. But let's have a look and see what we can see. Okay, the short of it is that the drop bear board or drop bear units will go on sale from next weekend, so 1 week away. I'm furiously putting them together at the moment. Spent all day yesterday doing it, and I'll be doing it for the rest of today as well. There is unfortunately a limited supply of these, and I do want to talk a little bit about why that's the case, because it's been difficult reaching this point with the drop bear. These had been aimed to be out a long time ago, and there's been one delay after another with them. And the reason for that is, well, partially it's on me because of the design work, but in a much bigger part, it's because of what's happening globally at the moment with the IC shortage. I'm sure most of you would have heard about this. It's affecting a lot of industries right now, and it's certainly starting to hit me in the development of this particular board. To give you an example, when I did the fourth alpha of these late last year, I was able to get and develop these boards, get them made, no worries at all. When I did the public beta of them in January, there was a slight shortage on some of the chips, but it wasn't really a major problem at all. And I managed to get those together, no worries. When I went to do the production run, and this production run, by the way, was ordered in March this year, that was meant to be a production run of 100 units to do an initial run with. We simply could not get one of the ICs here, and I'll show you which one. Let me zoom in here. The drop bear uses a chip that the plug and play boards have also used for a little while, which is a system basis chip. Now, a system basis chip is something that's designed to perform a bunch of different functions. Generally, in an automotive system basis chip, it will have a couple of voltage regulators built on, generally a heap of drivers, so a few relay drivers and those sorts of things, a hardware watchdog, and maybe some comms transceivers and those sorts of things. In this one, I have to unplug it here. But this little IC down here is the problematic one. And that's the system basis chip that I'm using and have used for quite some time. It's an MC33814. Really nice little chip. It has, like I said, dual voltage regulators on it. It has 4 drivers that you can use. Not particularly high current, but perfectly fine for driving relays. A VR conditioner built in, a single channel VR conditioner built in, which I'm not using here. Hardware watchdog. Bunch of different things. Really nice little chip. A few people have questioned why I used it, and there were a few problems with it initially, but ultimately it's a really nice chip, and I'm quite happy with it. That chip is now impossible to get. Straight up, it's impossible to get. The production run of these had to be cut from 100 down to 50, which is really unfortunate. Another board that I'm working on at the moment, I only went to do a prototype run of 7 of these. Could not get the chips to save myself. Ended up paying $42 a chip to get that production run finished, just because I needed those boards really urgently for another project. That chip is simply straight up unobtainable now, and I'm going to have to work on a replacement for that. To give you an idea of how bad the problem is, I went through ST Micro's catalog, and ST Micro are they're a micro manufacturer, IC manufacturer, and they're one of 2 or 3 that do a really, really nice series of automotive chips. NXP being the other one. They released a new family of automotive-specific ICs earlier this year. 2021 family of parts. Catalog was released earlier this year. And it's got a whole range of things in it, including system basis chips. So I was going through looking at that. Some fantastic little ICs in there, absolutely amazing, things that I would genuinely love to use. As best I can tell, none of those ICs have ever actually been manufactured. They've never hit a production run at all, despite being a brand new product and that there's a catalogue out there and everything for them. This is the state of the world at the moment with ICs. Anything that is in even a slight way specialised has just become next to impossible to get. And it's something that's going to be a real problem, I suspect, for at least the next 12 months. So I expect this will very likely be the last drop bear that uses that chip. As much as I like it, I'm going to have to find an alternative for it for the next run. And I suspect I won't find one single chip alternatives. I'm going to have to use multiple different parts to put in there. The reason why I don't like doing that is simply because of the physical size of that chip. I'm trying to think of something I can use as a really good comparison for how small this chip is. If I show you a USB connector beside it, in fact you can see this one beside it. That's a micro USB-C connector there. That whole chip is about the same size as the end of the micro USB connector. So it's pretty small, and it has an awful lot of features in a very small amount of space, which is going to be really difficult to replicate with discrete components, but it's probably something I'm going to have to look at. So enough of my excuses. That is unfortunately why it's taken so long to get to this point. It's been a difficult road. It's going to continue to be a difficult road. But I do have the first batch of these that will be coming available very shortly. Like I said, the plan is to release these next week. Okay, so most of you are probably familiar with what the drop bear is, but let's have let's have a bit of a run through. It's a 8+ 8 board, which means it's got 8 fuel injector outputs and 8 ignition outputs. It's powered by the Teensy 3.5, so a big step up from the Mega 2560. It runs this chip runs at 120 megahertz in this config. Honestly, it's not so much even that we need the power, it's the raw horsepower. It's got the additional timers, which is critical for the way the Speeduino firmware currently works, to get that for those extra channels. What you can also see in this picture is, let's have a look. We've got a map card up here. And the reason I added these is twofold. One, I needed to get a map sensor facing this orientation rather than coming up vertically on the board. And I also wanted to make it so you could easily change the values for this. So currently at the moment, this uses a standard 250 kPa sensor on it. So, you get 1.5 bar of boost up to 250 kPa total. But I plan in the future to offer probably a 400 kPa version of this board as well. And the really nice thing is it pops out very, very easily. Tiny little card, but can be swapped in and out very, very simply. Sure if we can get a better look at that. And these will be potted up as well before they go out. This one hasn't got there yet. There we go. Okay. Okay, yeah, you can see that's very easy. The way it works in the design of this board, if I put it back on, The base plate for this case, that way, actually lines up with the top of this board and holds it in place, so it doesn't have any vibration issues at all. And the hose itself pushes in against the sensor to maintain a good seal there. So the whole system works quite nicely from a mechanical point of view. The other big one around mechanicals is the USB connector here. This is mostly the USB connector is waterproof. The board itself is not fully waterproof. The goal had been that would be the case. In testing, I've struggled to get it perfectly waterproof. There is a seal that goes around here and things like that, but I've still had a couple of minor points where I get some water ingress at the moment if you submerge it for a few minutes, in particular around this area of the case here. That said, it's incredibly splash resistant. You can, fire a hose at it quickly and it'll be fine, but it's not fully submersible at this point. But it's something I'm going to work on for future revisions of it. On a fully sealed one, you obviously have issues with the barometric sensor on it. So there is a baro sensor built onto this board as well. So you get live baro readings as you go. And that's something that I'm fitting to most of the new surface mount boards that I'm doing. With that, you need something like one of these, which is a waterproof vent on the top of the case. You can see this one's got two, a black one and a grey one here. This is just my test case for working through where the best placement of these is. The best placement turns out to be roughly where that black one is for various reasons. But I'll look to include these on a future board once I sort out all of the sealing issues. And I don't think they'll be too difficult to sort out, but it's something that's not quite there today. Okay, so what else do we have on this? It's got pretty much everything that the Speeduino firmware at the moment supports is there and built in. So it's got a VR conditioner built in, a dual VR conditioner that is. It has support for standard Hall effect sensors as well as the GM 12 volt inputs. So you can feed a 12 volt straight into the cam and crank inputs natively if you've got a GM set up. It does have an optional stepper motor plug there, so you can plug in a DRV8825 if you need to run a stepper motor. As I mentioned, it's got the baro sensor built in. It does have a CAN transceiver built in, so it will support CAN out of the box. The CAN support in the Speeduino firmware is a bit of a work in progress at the moment. It's improving fairly quickly. And there's a lot of support there already today for the basic things. You can plug in an OBD reader and get some data off it. You can plug in CAN-based CAN-based tachos and things like that and get readings off them. That's all there today, and supported out of the box on these boards. What else? It does have, so obviously the Teensy board itself has an SD slot. Whilst this is not currently supported in the firmware, it will be in the future. This is one of the major areas of development at the moment, is getting the SD support. So as soon as that appears, you'll get SD out of the box and be able to plug in an SD card into one of these boards and have the logging capability of that work straight away as soon as the firmware is updated. It's fully compatible with Speedy Loader already, so you can just plug it straight in and grab the Teensy 3.5 version of the firmware. Teensy Loader was updated a few months back, probably about December, to add that functionality. You have to be using a firmware version from March or later for that, but it's all there. What else can I tell you from the hardware side? There is... let's have a look, actually. Let me flick back to here. No, not that one. This one. Okay. I'll just bring up the wiki page for drop bear. Oh, now, by the way, thank you so much to all of you who've donated throughout the stream. I haven't been able to catch you all individually, but thank you so much to every single one of you. It's a huge thing. I really appreciate that. Okay, let's have a look. So there is a page on the Speeduino wiki now for the drop bear. Okay, so a couple of things that we were discussing here. 8x8 outputs, that's standard. 6 medium current outputs, so all 2 amp outputs. 7 analog inputs, all your standard ones there. So your coolant, battery, baro, map, TPS, all those. Plus a few spare ones. I think there's 2 spare analog inputs on this that aren't used by default. 4 digital inputs, so you can use those for a clutch input or a VSS input or something like that, or flex, obviously. CAN transceivers built on onboard VR conditioner, swappable map sensors. Oh, there is a pin, by the way, for an external map sensor. If you'd prefer to use that, you just need to flick a slide switch, and it'll use and you can use an external map sensor with this. Onboard baro and optional stepper motor driver. Okay, so that's all fine. I'll come back to this one later. So these are the connectors. We've got a full set of the pinouts here, and you can go and have a look at this today if you're interested in exactly what's here and what the pinouts actually are. One of the connectors, the black connector, is all around the power and the inputs. So you get all your inputs on that side. Oops. And the grey connector is all the outputs. So you've got all your injector outputs, ignition outputs, and then your spare ones, boost fan, all those sorts of things. What else? In terms of the crank and cam inputs, to try and work with as many different setups as possible, I've added a small adjustable capacitance filter on this. So using a couple of small switches on the board, you can adjust the total amount of hardware filtering that's going on, depending on how many teeth you have on your crank setup. By default, it's configured to run with a lower than 60 tooth count. But then there's options for 60 to 100 teeth and 100 plus teeth. So that's just a nice little one that I've found to help make life a little bit simpler for as many people as possible. It's very difficult to choose a set of filter values that work really well for a 4-tooth crank input as well as a 60-tooth or even 120-tooth crank input. You simply can't choose one filter value that will work for all of those particularly well. So I've added this to give a little bit of flexibility in terms of what we can do on those crank and cam inputs to make life a little bit simpler and get a better result, hopefully filtering wise, no matter what your crank setup is. Okay, let me just have a quick look at chat and see if there's any questions coming through here. Okay, does it have a built-in wideband? No, it doesn't. For various reasons, I'm not a fan of building widebands into the board itself. I know there are a lot of ECUs that do it, and it is a philosophical type thing for myself. But I prefer to have that as an off-board unit because I think it provides more flexibility for people. It cuts down on cost if people already have a wideband controller. And a lot of people prefer to use a wideband controller that has a gauge and things built in. So no, it doesn't have an onboard wideband controller. I don't think that's a major issue. If you really want a cheap wideband now, you can get them for as low as I think $25. You can get wideband controllers for now. So that was something I chose to leave off on this board. Multi-spark discharge, that's an interesting one. I'd need to see what the use case for it would be. It supports, for example, leading and trailing sparks for rotary engines, and it might be possible to replicate a system similar to that for a twin spark plug engine, for example. If you had a twin spark 4-cylinder engine, your classic Alpha twin spark, for example, you could use 4 of the outputs for primary and 4 of them for your secondary spark. It's not something the firmware supports today, but the hardware is all here on the drop bear to be able to do such a thing. What else do we have? Oh, yeah, you will be able to add switches through CAN as well. Yep, Magnus, that's something that's not there today, but it is absolutely coming. The idea is that we have the programmable outputs section at the moment and programmable inputs as well. The plan is to make both of those take either an input as an output as being CAN. So that's the plan there. Some words on the 33810. Oh, some 33810. Sorry, I was thinking 33814s. Yeah, okay. So one of the other, where are we? Let's go that one. One of the other things I've done on this board, which is a little bit new, is use a nice integrated 4-channel injector driver, which are these chips down here, if you can see them at all. I know it's very difficult to see, apologies for that. But so these little chips, the MC33810s, are still available at the moment. Touch wood, that continues to be the case. So each of those chips has 4 injector drivers built in, 4 ignition drivers built in, although I'm using separate TC4424s just to give them a little bit more kick, a little bit more current. But the really nice thing about these chips is that they're controllable over SPI. So yes, you can use them in parallel, which means every output on them. So there's 8 outputs on every chip, 4 for fuel and 4 for spark. You can control them with an individual pin, but you can also control them with a SPI interface. And that's how I'm using it on this particular board, because it means that you can shrink the size of the whole board down dramatically. You need significantly fewer traces than what you would otherwise require, and it makes life a lot simpler in terms of actually laying these boards out. Yes, that there is code that's needed to support that, and that's all written now. You can see that on GitHub if you want. And in my testing, this has worked really, really well. I love this little chip. I think it's doing a great job. It's got a lot of injector-specific functionality built into the chip. It does also have some really fancy ignition capabilities that I'm not currently using, but I might look to use in the future. But on the whole, yeah, these are a really nice chip, and I'm very happy that I've elected to go with these because they're very, very compact, and they've let me do a lot of things in a small amount of space that would otherwise be very, very difficult. So yeah, bang for buck. That's what we're going for with those. That they have a lot of fault reporting in them. So yes, they do have short circuit detection and things like that built in, and you can read error codes and things back via SPI. Not all of that is currently implemented in the current code. As in, I'm not determining what the cause of an error might be, but the chip will go into a safety mode if it detects things like a short. So really, really nice. The reason I'm using the separate TC4424s in them is because I think the ignition outputs on them are, boy, it's been a long time since I've looked. I think they're only about 4 milliamp. It's a very small number. And look, that will be fine with 95% of the smart coils and igniters on the market. It won't be a problem at all. However, there are a few R8 coils come to mind, as do some of the VW coils that need about 20 milliamp to drive them properly. So, and in some cases up to 40 milliamp. So I just get a little bit nervous when the outputs are that low in terms of the ignition current. if you were using this chip and you were pairing it with a specific setup and you were saying, okay, my coil only needs 1 milliamp to drive or half a milliamp to drive, you'd be fine. But when you're trying to build a generic unit like this and cater to as much hardware as possible, I like to put a little bit of buffer in. And with the TC4424s, you can drive 500 milliamp, no worries. Not that you ever would for an ignition coil, but you do have that option there. So you've got these chips, the MC33810. The ignition output from that drives the TC4424, which then runs to your ignition output. Okay, so is heat a problem driving 4 injectors with one chip? That's a really good question, Mark, and that's one of the first questions that I had with these chips as well. So what they use is heat sinking through the PCB itself, which has become fairly common in modern PCB design. So these have an enormous copper pad underneath them that's used to sink a bunch of the heat away. These boards are a 2-ounce copper board, so they're using slightly thicker copper than a standard board. And realistically, that they seem to work just fine with that. I've run these at 95% duty cycle with fairly low impedance injectors, I think around 8 or 9 ohm, for hours on end, and you can feel them getting, or you can see them, because I'm using an IR camera for this stuff these days. You can see them getting mildly warm. You can see the copper underneath them, which is the big copper sinking pad that they use, getting slightly warm as well, but overall they stay a really nice temperature. And that's the way they're designed to work. That's what they're there to do. So a really good question, and a really nice little chip in my opinion. So Alan, thanks for joining the party a little bit late. This is the new drop bear unit that we're looking at here. I think that was probably most of what I had to look at physically on the board. I'm happy to do a quick run over of the schematics of these if anyone's interested. Like I said, they will be available in about a week's time. The price will be $380 US, and for that you get the unit fully assembled with the teensy, with the map card in the case, with a set of connectors and pins and lock tabs and everything. So you get everything that you need to hit the ground running. These connectors themselves are very, very nice in terms of crimping and things. You don't need a super fancy crimp tool to do it with. I'm using fairly standard crimp tools, and I do hope to have a limited number of these crimp tools available on the Speeduino store, just so that people are comfortable that they're getting something that will work. They are a very, very easy to use connector though. It's not like some of the very specialized connectors that are out there. These ones are very, very simple to use. What else? All right, look, let's have a quick run through of the schematic if anyone's interested. Okay, so around open source. This one will be opened, yes, but it's going to be, I'm not going to release the designs of this for a little while. And I know that does run to a degree against the philosophy of the project a little bit, but basically that's just to allow some time in order to get at least some sort of return for myself on these. I know from experience that as soon as I release these, other people are going to be manufacturing them. And there are other people taking the board designs and selling them themselves on eBay and AliExpress these days. That's totally okay. That this is open source, and that's the whole idea behind this. But I'm going to have a limited period after release where these will not be, the design files for these will not be opened for a little while. But I promise you they will be coming. All right, let's have a look. Just having a quick look through chat here. So look, not that I'm trying to make excuses here, but with the design of this, it went through 4 alpha stages, 2 beta stages, and then this release. So there's been a lot of hardware. I'd kind of just like to at least recoup some of the costs of that R&D before other people start manufacturing them. Okay, let's have a look at what we've going on here. The driver circuit's probably one of the more interesting ones, and this is what I spent a lot of time talking about. So we've got the pair of MC33810s here, 1 and 2. These circuits are identical, just duplicated, 4 channels and 4 channels here on each one of them. We've got all the SPI circuitry here, which runs them. And then the 4 fuel outputs, so each of those, 4 injector outputs. Each of those have an LED attached to them, obviously. And the 4 ignition outputs, each running via the TC4424s, again with an LED on each channel to your ignition output. I should mention the ignition outputs as well. The other nice thing of using the TC4424s is that you can have selectable voltage outputs for your ignition. That there's a switch on this board to flick between 5 volt and 12 volt, which is something that you otherwise don't get if you just use the 33810. Adding the additional chips is a little bit of an extra requirement there, but it does also give that functionality that you can have a 12 volt output if you want, which some coils do need. Yeah, so flexibility was the name of the game with these boards. They're trying to cater to as many different engines as possible out of the box. What else do we have that might be interesting here? So all of your inputs, this is fairly standard here. These are all the same circuits that we would use or have been using for a long time. Again, they're all fully protected inputs. They're all properly clamped. Got a baro sensor on board, the map sensor socket there. The only thing that's really different here is the fact that being a 3.3 volt board rather than 5 volt, the outputs from a lot of these run via a 5 volt to 3.3 volt op amp circuit. You could just use a resistor divider, but in my testing, the addition of the op amp it improves the signal quality and means you get significantly faster ADC reads. So that's a good thing to have there. There's a pair of those op amps. So these are the bulk of the inputs here, most of your sensors. And then there is another page with some here. So you've got some spare digital inputs here. These are for running, like I said, VSS and those sorts of things. Again, they're set up in a way that you can provide a ground switching input or a 12 volt input. They're fully protected against a 12 volt input. So there's no changes there, provided your 12 volt signal falls to ground when it's low. It will work fine with this circuit. And then you've got another op amp here for your spare analog inputs, which are, again, intended to be a 5 volt input. Crank and cam circuits, these have evolved a little bit over time. This is the circuit I'm using here to allow for 12 volt and ground inputs. If anyone's interested, I can talk forever on this. This is a deceptively simple circuit, but what it does effectively is barrier a 12 volt input and allow you to still have your same 3.3 volt square wave output, regardless of what the input voltage is, as long as the input actually falls to ground as well. So it can be 30 volts and 0 volts as long as it goes to ground as well. This is the variable capacitance circuit that I mentioned. So as it comes by default, both of these switches are closed, and you hence get the capacitance of both these capacitors working on the filter. These values were chosen fairly carefully to be as flexible as possible, and you can therefore then get a nice range of values by alternating your switches here. So I think from memory, if we can even look, what did we say? So yeah, less than 60 teeth, both on and on. If you've got 60 to 100 teeth, switch 1 is on, switch 2 is off. So there you go. You'd get 4700 PF of capacitance if you had just that switch on and this one off. You can, of course, turn them both off, which I wouldn't ever recommend doing on a car, but is really useful for stim testing if you want to plug a stim directly into it. And you can then have no filtering getting in the way there at all. Again, you've got the switch. This is all obviously running for a Hall input. You can flick your VR input there and it'll flick over to your standard Max 9926 VR circuit. This is the same one that's been in use on the VR conditioners forever. So it's well tested. It works really well. I have no real concerns about this. The only other thing that this circuit here has a dedicated jump switch, a dedicated jumper on there, just in case you've got a somewhat weak ground that's not pulling this circuit to ground properly. You can just solder on that jumper and it'll work really well. So that was one thing that came out of the beta program. Some people, or one person, was noticing that because they had a bit of a weak ground on their CAS input, that they needed to pull this one to ground directly rather than going via this circuit. Again, just put there in the name of flexibility, so we can work with as many engines as possible out of the gate. In terms of comms, there is too much. The CAN transceiver built on. Again, this is fairly standard. There's nothing really fancy going on here. MCP2562 is a fairly standard CAN transceiver that we're using. We use the Teensy has native CAN out. It just needs the addition of the transceiver on the board. There is an optional terminator resistor here, and you can just pop a jumper on and have a terminated CAN circuit in case you want to test on the bench. Obviously, in a car, you don't want the terminator resistor to be on, but it's there just in case you do want to do some bench testing. What else? What do we have? Yeah, there is an accelerometer circuit on this board as well. It's not populated on this original board, so I was having a few issues with that. Yeah, it's something I'm keeping up my sleeve that might appear a little bit later. There is a Bluetooth header connector on this as well, and there's also some additional flash storage that's on the board there today, just for future expansion. All right, I think that's probably the most interesting circuits. We could have a look at the power circuit if you'd like, but there's nothing particularly interesting about it. I've finally wised up, and I don't know why I didn't do this a long time ago, and I've added full set of power LEDs to these boards, something I should have done a long time ago. So you've got an LED for 12 volt power and for your two 5 volt rails. There are two rails that these run. There's a power rail and a dedicated sensor 5 volt rail on them. So you get LEDs indicating that they're all working fine. Nothing too much out of the ordinary on this particular circuit, I don't think. Let me have a look for your look at chat quickly. No, these will absolutely be shipping globally, so it won't just be AU. I'll be shipping these anywhere. For the power regulator, good question. I think it's a 1 amp regulator. It's not a huge amount, but there's nothing on these boards that uses a significant amount of current for 5 volt anyway. And if you have a look, for example, at the where would it be? Here. You've got, so these are your two 5 volt rails, your standard power and your analog power. Your analog power, it goes via a polyfuse before it goes out of the board anyway. So that's a slightly more protected circuit than this one, just in case you do something dumb and you short your 5 volt reference signal. Nothing should be powered off this board, off this 5 volt signal. This is only for reference to your TPS, for example, would need this 5 volt reference. No drive-by-wire on this. So drive-by-wire I know is one that's a little bit contentious. A lot of people ask for this, but it's not something, at least at the moment, that I'm comfortable implementing in the firmware. The liability and the safety issues that go with it are quite extraordinary. I've made a drive-by-wire circuit before. I ran it, I set it up. I thought, I'm really comfortable with this. It did all the proper reverse circuitry stuff, so it was doing the circuit comparison between the increasing and the decreasing circuits, all those sorts of things. I'm still not comfortable implementing that for something for general use. So I get that will upset a few people, but that's the stance I'm taking on that at the moment. It might change in the future. It might be a separate device, simply because safety. Most OEMs use separate drive-by-wire controllers. It's not built into their primary ECUs, and that's a safety factor thing as well. So I know there are drive-by-wire controllers out there that you can use. That's probably your best option if you don't want to flick to a cable throttle at the moment. The purchase will be through the store on Speeduino.com. So yes, and that will be available from next weekend. I'll do a big announcement on Facebook and everywhere else, but they're only about a week away, just to give me some time to assemble the remaining ones. I'm about 2/3 of the way through the assembly. Why not the 2596? Which circuit are we looking at for that? CSG Tech. Yeah, it will be limited, sorry, as well. I meant to mention to one per customer initially. Again, it's unfortunate. I didn't want to have to limit this batch as much as I have, but it's simply the reality of the world we're in at the moment that I just had to cut the production run down. It's not where I wanted to be, but it's unfortunately where we're at the moment until I can work on updating this design a little bit to get rid of this circuit here, to get rid of this 33814 and replace it with something else. Yeah, so Tom, will there be a way to easily run 6 cylinders? This supports 8 cylinders out of the box, up to 8 cylinders. So you can run 8-cylinder sequential, 6-cylinder sequential, anything you want. You can run, once the firmware gets updated, dual sets of injectors on 4-cylinder sequential, for example. Anything up to those 8 outputs will be supported. So absolutely, 6-cylinder sequential, fuel and ignition, 8-cylinder as well. It's all there today. The firmware supports all that already. Yeah, so absolutely. The release time will be either next Friday or next Saturday. Absolutely. No questions asked. It'll be one of those 2 dates. Probably the Saturday, I suspect. So 12-cylinder and 16-cylinder wasted spark support will be coming. I am working on that one. It's not there today, and strangely enough, there's not a lot of demand for it, but it absolutely will be coming. I promise you that will be there at some point. And yes, I do have one person working on a 12-cylinder engine, but that's another matter. Yeah, so the MC33814 is an automotive-specific circuit. It is an automotive-specific IC, yes. Yep. Can I repeat the injector driver's name? I can, and I'll even show it to you. It's an MC33810. There you go. Okay, well, I think we're probably just about coming to the end of things for today. Oh, okay, Speeduino. I should mention Speeduino. Okay, so this is the drop B unit, and these other boards have been my focus for a little while. I know there's a lot of people who keep asking about Speeduino. I haven't forgotten about it. It is still there. I'm going to, in the interest of getting something out the door, do a simplified design that doesn't have the fancy OLED display and everything. It'll be cheaper and much, much quicker to get a board designed for that. Now that all this is starting to get sorted out, I need probably a few more weeks to sort out what the next production run for these will look like, and get some slightly updated designs done to replace those ICs that we can't get. but then I will work on a simplified Speeduino design. The firmware is basically all written. It's all there today. It needs some tweaking. The UI, as in the graphical package that configures the unit, needs a little bit of work, but is well along the way as well. What I'll do is get a simplified hardware design out. It'll basically just be a black box unit with a connector on the end and some documentation. But it will work with one of these. You can use one of the spare digital inputs with the Speeduino, and it will work fine. There might be an option to use one of the analog inputs to get varying levels. I'm not sure yet. But yeah, that's my plan for the Speeduino. Not scrap, but push back the whole fancy OLED gauge design, which is still hanging around on my desk. It hasn't gone away. But then again, there's a lot of things hanging around on my desk. It will still come out one day in that package. But I think in the interests of getting something out the door quickly, I'm just going to do a really basic unit. It'll have all the circuitry on board. It'll be programmable. It'll have all the proper decent knock features, all the knock windowing, the variable filtering, the proper curves for different filtering levels at different RPMs, all that sort of jazz. It'll do the job of knock properly. It won't be a toy knock. And it will hopefully be fairly cheap to produce and easy to produce if I defer the whole OLED idea for the moment. I maybe got a bit ambitious with that, given everything else that was going on. Okay, what else is happening on chat? No set date for the Speeduino release yet. No, right. Yes, Speeduino will use generic sensors, and it will be dual knock. So if you've got two knock sensors on a V engine, V6 or V8 or anything, yes, it will work with both. Will I be doing any more live sessions on a semi-regular frequency? That's a good question, Chris. Look, I should. I guess I'm not really sure what you guys want to see from me. This one I did because I've got so much stuff going on in the hardware space at the moment. Obviously, the drop bear release was the big one, but we had the new through-hole board and the connector, the shield board for that and everything. There was a lot going on, so I felt that justified a stream. I plan on getting like a regular YouTube video out just to run through the features of what is on the drop bear, to have that to go ready for the announcement or ready for the release next week. I don't know. Let me know what you want to see in these streams, and I'm happy to do them on maybe a monthly basis or something like that. Whatever you want to see, I guess. I kind of feel like I don't know what I should be talking about, what people want to see, but I'm more than happy to do them if there's interest. Look, again, thank you so much, everyone, for all the donations that you came through. That's really fantastic. I really appreciate it from everyone. What's the best way to contact me? Depends what it's for. I'm on Slack at the moment. Is probably the best way, the Speeduino Slack team. I have been thinking maybe of converting that to a Discord channel, to a Discord server. I'm not set on that idea yet, so if you've got any thoughts either way on that, let me know, either in the comments or let me know on Slack. We'll probably discuss that. I just think when I started the Slack team, Slack was absolutely the better way to go, but I think where Slack is now and where Discord is, maybe it's shifted in favor of Discord. I don't know. Happy to get you guys' thoughts on that one, but probably through Slack is the best way to get a hold of me. What else? Dedicated ITB mode. So there isn't... I always ask the same question. What do you want to see in a dedicated ITB mode? What is a dedicated ITB mode for you? I run ITBs on my test car, right? That's what it has set up at the moment. And I run a dual multiply map setup. So you've got two fuel maps, one operating on a TPS load and the other operating on a map load. And I have the two merged together and one multiplies by the other. That works really well. In my opinion, that's the best way to do ITBs. It lets you do boosted ITBs if you're a crazy person. But it also gives you pretty much all the flexibility that I could think that you want, and it runs really nicely for me. If that's what you consider to be a dedicated ITB mode, then yeah, it's there today already. But that in my opinion, is the better way to go. So dual fuel map and merge them together so they run together at the same time with multiply. Okay, Alan. Yeah, look, that there is, if you go to the, if you shoot me an email at sales@speeduino.com, I'll get anything that's related to an order. Yeah, so there are 2 fuel tables today. You can set them up in, hang on, I can show you, but I haven't set it up on this machine yet. Bear with me a second. But yeah, there are 2 fuel tables today. You can have switched fuel tables, so you can have it run on one and then switch to the other, or you can have them in hybrid mode so that it uses both tables at once. You can tell how long it's been since I've used Tuner Studio on this machine. Okay, this firmware is new enough that it will have it. Where are we? So you can add a second fuel table. You can have them multiplied %. So the 2 tables will be multiplied together to give one output. This is how I run my ITB setup. You can have them added, so it will add one on top of the other. And again, the only reason you do this is if your fuel load on the secondary table is different to your fuel load on your primary table. Or at least that's the only reason I could think to do it. And you can also have switched tables, so it will switch from one table to the other. You can have that based on a condition. So when map is greater than, say, 100, so you would have it flick to the secondary fuel table when boost kicks in, for example. You could have it based on TPS, so when you put your foot to the floor, it switches to the second map. Or you can have it via an input based. So you can have a physical switch in your car, flick the switch, and it will go to the second map or the first map, depending on what the switch is set to. But yeah, that's all there today. It's been there for a couple of firmware releases now. What else have we got? All right, I think I've answered most of the questions in chat by the looks. Cool. I think we're probably done for today. Hopefully you all enjoyed it. Hopefully you all liked seeing the new hardware. It'll be out soon. I hope it's been tested to death, this hardware. It really is, in my opinion, a nice design. It's not just a beta product. This hasn't just been thrown together and we hope it works. It's had so much testing, it's ridiculous. It should work really well. It seems to work on all the test units that we've got out there. I'm really excited to get this out there. It's been a long time coming. It's been a lot of work for myself to get to this point. So I'm really happy to see it finally come out the door, given the teething problems that we've had trying to get hardware. But yeah, I hope you've all enjoyed today's session. I hope you have a great night for those whose evening it is. For those like me in Australia or this part of the world, I hope you have an amazing Sunday. I'm going to go hit the shed and start putting together some more drop air units. Have a great